My name is Folsom. I'm here to present some topics about you, and this one in particular is about how our soils form. Now, does anybody, before I start, know how they're formed? Nope, nobody, not even a little bit? Okay. Well, good thing I'm here then. Maybe you'll learn something. So there's 5 factors of how soil is formed, and they're climate, organisms, which is biology and vegetation that is in the environment, relief, also known as topography, which is like how the land it lays and everything like that, and parent material, which is what gets weathered or turns into a soil, and time, because we all know that Rome wasn't built overnight, so just like that, parent material can't be turned into soil, in one day. So first thing we're going to talk about is climate. Climate is the temperature and moisture, and they influence the speed in which the chemical reactions turn the parent material or stuff around it into soil, which means they weather or decompose. And so you can see there's got 4 different pictures up there. And soils that develop the fastest are warm and moist climates, which would be something like the jungle here, because it's just a breeding ground for bacteria. And the slowest are cold arid, which would be like Antarctica. The soil doesn't ever really change there because there's nothing living there to help break down the rocks and minerals that are there. It's basically all they have is the wind and snow, because it never gets warm enough to unthaw. Now, there's organisms. So, does anybody know what an organism is?
Yeah.
Okay, what is it?
A plant or animal.
There you go. Gotta make sure you're on your toes here. So, plants spread out, and animals burrow, and worms dig through the soil. These are all things that help break up the soil and keep it from getting compacted. These and other soil organisms, they break down the organic matter or material that's in the soil, which in turn helps everything else turn into soil, and it takes the larger particles, such as like a big dirt clod. If you had that and a worm got into it, the worm would dig its way around in that until it eventually broke into little pieces, and then those little pieces, something would latch on that and break those down, so it slowly breaks everything down into small particles. Organisms. There's so many different ones. For instance, it could be the roots of a tree expanding into the soil to let water and air go through it. It could be water on the cracks of a rock. And birds, for instance, birds, if they, for lack of a better term, crap on a rock, in that organic matter there's acids in their feces. So when that gets on a rock, it slowly wears away at it, and eventually it'll break the rock in two. It might take, tens of thousands of years, but enough times that bird craps on a rock, then it'll eventually break it in two. So relief, or topography. It's the shape of the land and the direction, the slopes and everything like that. So, go ahead.
Before I start this one, I was going to ask you, so what do you feel like with your classes, what's the quickest type of plant or animal that breaks down the quickest to turn into parent material?
So, what I feel, there's so many different types.
Yeah.
It's hard to pinpoint an exact which one is the fastest. But I would say first off, it all depends on your climate you're in, because if you're in a warm, moist climate, there's going to be a lot more different things to break down. There's going to be a lot more bacteria, bugs, and animals that can break down. But if you're in a cold, arid, if you're in Antarctica, there's not many animals there. So probably bacteria, just as a whole, because there's so much of it, and because there's such a large quantity, it can work the fastest. So you can see this looks like a pretty sheer drop off, and so if it rains there, the water is going to run down very quickly, which is going to pick up more soil and carve away at the rock there. So that'll be a factor. Another factor is if it gets a lot of sunlight. Because if it gets a lot of sunlight, it could be a lot more bacteria and moss there, which helps dig into the rock and break down things. And it also depends on how much water stays in a certain area. Like this was a very sheer drop off, but if it's very flat or has like a bowl shape to it, water's gonna sit there. And so that's another thing that could happen. And the deeper the soils form at the bottom of the hill, because all the soil is washed off from the top of the hill and makes a big pocket at the bottom. So it's usually it tends to be very fertile at the bottom of the hill because that's where it's been spent the most time decomposing and turning into soil. Now, you'd never think there's so many different names of just a hill. You know, different things you could list on a hill. So the top of it is a slope or a hill is the summit. And as you work down, there's the shoulder, the back slope. When you get towards the bottom, there's a foot slope, and at the very bottom, there's a toe slope, and then the drainage way. So, let me ask you guys a question. Do you think that the soil at the top of the hill is the same as the bottom?
No,
Well, why do you think that?
because it all washes down to the bottom.
Well, that would mean, if this soil up here is this, let's say it's very fertile ground. If it all washes down here, wouldn't that mean this is still fertile down here? But the point I'm getting at is that the water affects and the climates affect the different slopes differently. So, in turn, I'll show you here. See, I don't know if you can't see it very well, but at the very top, it's a darker soil. Well, actually, it's more red, and it gets darker the way it goes down. And it can tell you how the soil behaves is the color of it, because when it's bright, that means it's well drained, and at the bottom, in the drainage way, the soil is so waterlogged that it turns almost a little bit of a gray color, because it's essentially kind of not quite molding, but like there's just so much water it can't function. Parent material. So you guys all have parents, and you came from them. So just like it happened with you, the same way as with soil. You inherit certain characteristics from your parents, just like soil inherits characteristics from its parent material, for lack of And soils that form in limestone bedrock have high calcium levels, where soils that are formed from materials at the bottom of lakes are high in clay. So, like I said before, the characteristics from a soil you see now is how we can backtrack tens of thousands of years and see what the soil came from. Now, there's transported materials that could run down the hills or be carried through streams. And there's also bedrock, residue, material, and organic materials that all play into soils along with parent material, because everything affects one another. It's like a chain reaction down the slope. So transported sediments is a couple forms of those is water transported or deposited, which is fluvial and lacustrine. Sorry, kind of a tongue twister. And wind deposited soils are alluvial or alluvium. Sorry, but like that's loess soil. So the hills that we have around here, they're loess hills, which means they're wind deposited from the tens of thousands of millions of years ago. They were wind deposited here, whereas a lot of the other soil around here is glacier deposited, which is another one. A glacial till came in and deposited soils as it pulled back, so that's why there's different types. Gravity transported. So what would be an example of gravity transported? Besides, there you go. You guys got any other ones?
What did you say?
Rock slide.
I don't know.
It's kind of the same, but mudslide is another example. And that's colluvium. they make all these big fancy words, but you just gotta know that colluvium is gravity transported or transformed, and not all the fancy words. It's a lot easier to understand if you can just tie the words together. So fluvial is the sediments are deposited by rivers in our floodplains. So we have the Missouri River right next to us, and if you go out there, you can see there's lots of sand around there from when because it flooded, 5-6 years ago.
Yeah.
And so that's a good example because when the river came back into its banks, it left a bunch of sediment out on the sides. So that's just an example to kind of relate it to make it a little more easy to understand. Bedrock or residual material. These have a lot more. These properties are contingent on the minerals present in the parent rock when it's weathering. Like if it's got a lot of clay and minerals in it, and also the particle size. Because if the bedrock breaks into big particles, that means the minerals are still bonded together. Whether it breaks into small particles, where the minerals are a lot more accessible. And time, the big kicker here. The older soils differ from the younger soils because they've had longer to develop, and believe it or not, just like humans, soils age. They are constantly changing. Once we can classify a soil, it keeps getting older and older and changing. So just because, for instance, like the Nile River Valley, when Egypt was a thing, and not Egypt, but the Egyptian Empire, because it's still a thing, it was very fertile. And so, but now if you go there, it's nothing but really a swamp. It's hard to get things to grow. It's because the soil has been used so much that it's now infertile.
So do you think Iowa will get like that eventually?
I do believe eventually, if we do not take care of our soil that we have and keep putting nutrients back into it, we could end up just like them. Because if you mine the soil, you're taking out all the nutrients and the minerals, and so if you do that, it's just dirt that can fly around in the wind. But in the northern U.S., soils tend to be younger, because like I said earlier, the glaciers came in and tilled up a bunch of ground, and then when they receded, they deposited it all. This was the last big soil formation event that we can record. I mean, obviously the wind and water erosion keeps forming soils, but the last ice age, when the glaciers receded, was the last big soil formation. Where the soils have been exposed for a longer time, they tend to be weathered. Like in the deserts, you can see there's nothing but really sand there now. There's nothing, and a million years ago there might have been a lush forest there, but as time goes, climates change, which helps affect the soil, and then things change. So before you answer any questions, there is one more thing that affects soil, and I honestly believe it is the biggest thing that can affect soil the quickest, and it's humans. Because if you think about it, we can go into a forest that's been growing for 100,000 years, and we can wipe it out in 10 years. We can take all the trees off it, and now that loose soil is there, and it can just blow away. Because you think about it, just in the last 10 years of things you've seen, how many buildings have gone up and farm ground's been taken out? Or hills been leveled for houses. The nature can't do that, overnight like humans can. So that's personally what I believe is the biggest soil affecting factor, because if we don't watch what we do, we can ruin nature twice as fast or 10 times as fast as anything else I just read off. So, do you guys have any questions? Are you confused about anything? That's a better question.
Not really. Like, what's the best chemical that you could use to break down rocks, or what's the best chemicals to put back in the ground?
Well, for chemicals to break down rocks, that's more of like naturally occurring chemicals, like there's natural acids the examples off the top of my head, but that's what breaks down things. And for chemicals you'd want to put in the soil, I don't know if you'd really call it a chemical to put in the soil, but you'd want to put like, depends what your purpose is, honestly.
Yeah.
If your purpose is to farm, there's a lot of different things you have to put in the soil than if your purpose is to build a house. So, you guys understand everything I just listed off? So, if Mr. Thompson were to give you a test at the end of the period, you could get 100%. Okay. Well, I guess thank you for having me, and I hope you did learn something.